Going on, guys? In this video we are going to see how to calculate complex powers. In this particular problem we have asked to find out the complex power absorbed by this 1 ohm resistor, negative 10J capacitor, 5 plus 10J impedance and the source. Okay, now in order to find the complex power we are going to use this equation. S is equal to Vrms times Irms conjugate, and to find this voltage we are going to use V is equal to Iz. In both cases we had to find out the current, right? So we are going to solve for the current first, then we are going to do this problem. Now to solve for the current, what we are going to do is we are going to take the Kirchhoff's voltage law, and if we apply Kirchhoff's voltage law in this loop right here, this is going to become negative 120 degree, because this I1 current is going from negative to positive, right? So this is going to be negative 120 degree, and after that this I1 is going through this 1 ohm resistor, so this is going to be 1 times I1, and after that this is going through this one. Here we have two impedances in series. When we have impedance in series we can add them together. We treat impedance same as the resistor, so this is going to be 5 plus J10 multiplied by this current I1, and if you look at this I2, this is going in the opposite direction, right? So opposite direction means this is going to be negative, and that should be equal to 0. And if you add the like terms together and create the equation, you are going to get 6 plus 10J times I1 minus 5 plus 10J times I2 is equivalent to 120 degree. Okay, now let's call this one equation 1, and we have to create another equation because we have two unknowns, right? We have I1 and I2, two unknowns. To create another equation we can use the other loop. In the other loop I2 is going through this negative 10J impedance, so this is going to be negative 10J I2, and after that I2 is going through this one. Here we have 5 plus 10J times I2 minus I1, because I1 is going in the opposite direction, so minus I1, that should be equal to 0. And we have two equations. Now if we combine like terms together, this is going to become negative 10J times I2, then plus 5 plus 10J times I. Oh, okay, I made a mistake. Let's write this one again. Okay, this is going to become negative 5 plus 10 I1, and after that we are going to have plus 5 I2. This is equal to 0. This is our equation 2. And since we have two equations, two unknowns, we can solve for each of them. And if you calculate these values, you will get I1 is equal to 5.15. Okay, wait a minute. This 5.1592. The angle is 25.5 degree, and I2 is going to become 11.5363, and then 88.9 degree. Okay, so these are the currents we have. Now we can go ahead and solve for each of these, like each of these situations. First we are going to find out the power absorbed by this 1 ohm resistor. Okay, let's write this one here. Let's get rid of this part. This is just to show how to get this I1 and I2. Okay, now we are going to go for the real question, that is to find out the complex powers. Okay, now first, through the 1 ohm resistor, first we have to calculate the voltage. Voltage is equal to I times Z, and in our case I through this 1 ohm resistor is I1, right? I1 is 5.1592 to 25 degree angle, so 5.1592 25.5 degree multiplied by the impedance, and the impedance is just 1, and if you, that's going to give us the same value, right? We are going to get the same value, 5.1592 25.5 degree. This is going to be the voltage. Now we are going to calculate the power. To calculate the power we have to use this equation. S is equal to Vrms times Irms conjugate. We just found out the V. This is 5.1592, 25.5 degree, multiplied by the current conjugate. In our case, current is I1, right? I1 conjugate mean we just change the angle, like we just change the sign of the angle. So here we have positive, we are going to change this one into negative. And if we do that, we are going to get 5.1592 negative 25.5 degree. Okay, and if you calculate this one, you're going to get 26.617 in polar form, and if you convert this one in rectangular form, you're going to get 26.617 plus J0 volt ampere. So this is going to be the power absorbed by the 1 ohm resistor. Now the next thing is we are going to calculate the power absorbed by the negative 10J capacitor. Negative 10J is here, and let's calculate the voltage first. Let's get rid of this part. We need these two, but these are the two important things. You know what, let's note this one down here. I1 is equal to 5.1592 25.5 degree, and I2 is equivalent to 11.5363 88.9 degree. Now let's get rid of this one. Okay, we are going to do the second part here. Second part is asking what is the power absorbed by this negative 10J capacitor. Here first we are going to calculate the voltage. Voltage is equal to I times Z, and here I2 is going through this one, right? So I2 is equivalent to 11.5363, and the angle is 88.9 degree multiplied by the impedance, that is negative 10J, and if you calculate this one, you're going to get 115.36 negative 1.1 degree. So this is our voltage. Now we are going to calculate the power. Power is equal to Vrms times Irms conjugate. Now let's directly put the values. Vrms we found out that is 115.36 negative 1.1 degree multiplied by the Irms conjugate. Here this current is I2, so I2 conjugate is going to be negative angle, so this is going to be 11.5363, and the angle is going to be negative 88.9 degree. And if you calculate this one, you're going to get 1330.86 negative 90 degree, and this is in polar form. If you convert this one into rectangular form, this is going to become 0 minus 1331 J volt ampere. Okay, so this is the second part. Now let's go to the third part. Now let's get rid of the top part because we need some space. Okay, so this is our third question. What is the power absorbed by this 5 plus 10J impedance? Here we have 5 plus 10J impedance, and if you look at this one, first let's calculate the voltage. V is equal to IZ, and the current through this one is going to be I1 minus I2, right? I1 minus I2. Okay, so we can say I1 minus I2 or I2 minus I1. Let's say I1 minus I2. I1 minus I2, we have to just subtract these two values. I1 minus I2, and if you calculate this value, you're going to get 10.315 angle negative 64.5. Okay, 64.5, then 5 plus 10J, and that's going to give us 115.328 negative 1.1 degree. So this is our voltage. Now we are going to calculate the power. S is equal to Vrms times Irms conjugate. So Vrms is going to be this voltage, 115.32. Let's write 33. If we round this one, this is going to be 33, and then negative 1.1. And the current we are going to use is this calculated I1 minus I2. but we have to change the sign, right? Because we are doing the conjugate, so the sign of the angle is going to change. Before we had negative, now this is going to turn into positive. 10.315, angle is going to be 64.5, and if you calculate this one, you're going to get 1189.6, 63.4, and this is in polar form. If you convert this one into rectangular form, this is going to become 1189.6 cos 63.4 degree plus J 1189.6 sine 63.4 degree, and that's going to give us, if we simplify this one, that's going to give us 533 plus J1064 volt ampere, and that's going to be the final answer for this one. Now we have one more part left. We have to find the power absorbed by this voltage source. Let's get rid of this one. Okay, first we have to calculate the voltage. Voltage is already there. V is equal to 120 degree, and power is going to be S is equal to V times I. Voltage is going to be this one, and to mention this is a supply, we have to put a negative sign, right? Negative. Let's create the general equation. Negative V I conjugate, and negative this voltage is going to be 120 degree times I. In our case, I is going to be I1, because I1 is the one going through this voltage source. So this is going to be 5.1592, and the angle is going to be negative because this is conjugate, negative 25.5, and if we calculate this one, this is going to give us negative 559 plus J 267 volt ampere, and that's going to be the answer for this is fourth part. Okay, fourth question. I hope this helps. Thanks for watching.